So be focusing on that. Because as Mr. Passwater said, it's essential. Remember, we used exactly that it's a big deal. Right? Okay, 3, here we go. Just a quick review of what we've already talked about. Cosine is x over r and sine is y over r. Those definitions, some of you are thinking, wait, well you told me x was cosine. Well, I told you x was cosine where? In the unit circle. So if r is 1, then x is cosine. But in general, everywhere, cosine is x over r. Those equations can be written differently. X equals r cosine theta and y equals r sine theta. Would you agree with that? We are going to use the equations in this form a time when we get the polar coordinates later on in this unit. But for now, let's just recognize that these are equivalent statements. Okay, so when I look at example 1, and it says we got this triangle PQO, here's my circle, and I'm talking about point Q now. Don't let all that stuff confuse you. You know what point Q is. What's point Q? What angle? What angle is point Q? Two pi over 3. That's 2 pi over 3. This would be 3 pi over 4, and this would be 5 pi over 6, right? That one's 2 pi over 3. Do I know the radius of this circle? 4. The question says, what are the coordinates, or what are the coordinates of point Q? So in other words, what's x and what's y? Well, x is r cosine theta, and y is r sine theta. So the answer to question 1 is C. It's that easy. Don't let it mess you up that he writes so much stuff. Just this. All right, example 2. Now we've got a line y equals negative x. Okay, so we know what that is. That's this guy right here. So before we go, yes.
For the other one, why wouldn't it be d, which is negative? Or would it? I don't know what
I know what you're saying, right? First of all, you're letting your, this is the fact right here, okay? Now think about what would happen if I am in this quadrant. The coordinates in this quadrant are negative, positive, by virtue of being in that quadrant, right? So if this right here is already negative because it's in that quadrant. If I put a negative out here, then it becomes a positive, and it is not positive in that quadrant. You see? So R is R, period, right? And the angle is the angle. Now, if they hadn't given me the correct angle as an option, then I could, this angle could be named other ways. We talked about that yesterday. So I could have had this angle be negative 4 pi over 3, and that would be okay, because isn't negative 4 pi over 3 in the same spot? since they gave me 2 pi over 3, that's what I'm going with. But that change I can make. I can
Okay.
alter my angle, but I'm not messing with my radius. Okay. All right, so this is the line y equals negative x. Before we go any farther, I don't even know what the question's asking. Can you tell me anything about these two angles? What are those two angles? 3 pi over 4 and 7 pi over 4. So I don't know whether I'll need that or not, but that's unit circle practice. Got it? Okay. By the way, on the unit circle, what would be the coordinates of that point on the unit circle? What would be the coordinates of that point? Charlie? Negative root 2 over 2 and root 2 over 2. And this one is the opposite. Root 2 over 2, negative root 2 over 2. Everybody okay with that? That would be if the radius is 1. Okay, I gotta go back to the problem here. If the coordinates of point P, okay, so the actual coordinates of point P are 6 root 2 and negative 6 root 2. Well, that makes sense that they would be positive and negative, right? But clearly we're not in a unit circle. Clearly we have a different radius. And our job is to find the radius. Yeah, our job is to find the radius.
Just multiply the radius of the unit circle by 12.
Exactly. Yeah, let's, how can that be logical at all? Well, let's come back here for a second. I know my angle, right? And I know the cosine is root 2 over 2. So if 6 root 2, that is x, has to equal r times the cosine, which is root 2 over 2, then I can solve for r, doing exactly what he said. I'll multiply by 2 and divide by root 2, so r is 12. What Leo said was, take the triangle in the unit circle, there's the triangle in the unit circle, and blow it up so that this is a 6 root 2, and he said, in order to do that, I'm gonna have to times everything by 12, would you agree?
Why didn't you just take the cosine out? Like, why did you just put a root 2 over 2 and not cosine root 2?
Oh, remember, the cosine of the angle is root 2 over 2. That is the cosine. The angle is 7 pi over 4. Is that what you're asking?
Yeah, I just like a little confused where you got root 2.
Okay, so exactly. Your sines and cosines, sine and cosine, aren't going to change. In any circle that you draw, the sine of pi over 4 is root 2 over 2. Okay, I can get those straight from the unit circle. If I blow my circle up, then what changes are the coordinates, x and y, and the radius. This is what changes. The ratio, adjacent over hypotenuse, opposite over hypotenuse, the ratios don't change. Every time you see a pi over 4 angle, you're going to have root 2 over 2 as your sine and cosine. That will never change. Okay? So that's why that unit circle is so important, because it gives us the sines and the cosines for all those angles. Okay? So that will never change. That's an important point. If I have a 45-degree angle, In geometry, I memorized that 1 root 2. So the ratio of opposite to adjacent tangent is 1 to 1. If I blow that up and make it a bigger triangle, so 3 root 2, 3 root 2, 6, if I blow it up, isn't the ratio of opposite and adjacent still the same? So the x and the y can change, the r can change, the size of the picture, in other words, can change, but the ratios will always be the same. So when you memorize your unit circle, you are memorizing that the cosine of 2 pi over 3 is negative 1/2. Always. All right, speaking of unit circles, here we go. Find the values of the following. Example 3. This is a unit circle, therefore cosine will be x, sine will be y. So here we go. Cosine 0 is 1. Sine 0, 0. Cosine pi over 2, that's straight up, right? Pi over 2. Cosine is 0. Guys, one more time. Cosine's x, sine's y. Figure out where you're at. Cosine's x, sine's y. So the sine of pi over 2 is 1. Cosine pi, negative 1. Sine pi, 0. Cosine 3 pi over 2, 0. And sine 3 pi over 2, negative 1. Easy, easy. Let's go ahead and jump to example 4. There's a lot of reading there, but I think you've already talked about all of it, so let's just see if we can do example 4. The figure above shows a unit circle with some triangles in there. Use the symmetry of the unit circle to find the coordinates and angle measures for all of those points. Okay, so it looks like we're looking at our pi over 6s. So if p is pi over 6, what will q be? Here's a mistake. 5 pi over 6? And what will r be? 7 pi over 6? And s is 11 pi over 6. Okay, so these are all of our pi over 6s. Now, what do we know about the pi over 6s? I always have to keep my first quadrant with me. At pi over 6, this is what I never went anywhere without this right here. So pi over 6 is root 3 over 2, 1/2. So I know that for every single pi over 6, that's my point. I just have to change something to negative. So for point P, that's quadrant 1. So that's root 3 over 2, 1/2. What is it for point Q? Negative root 3 over 2, positive 1/2. How about R? Both are negative. And S? Positive, negative. Everybody okay with that? So again, the power of that is, if you're doing a problem, and all of a sudden you have to know what the sine of 7 pi over 6 is, you know what the sine of 7 pi over 6 is. Negative 1/2. Right? Is that easy enough? Easy enough? Okay. Let's see. Let's look at example 5. Same thing. Example 5. Only now our angle is pi over 4. So what are those angles? Pi over 4, 3 pi over 4, 5 pi over 4 and 7 pi over 4. Very, very good. And the ordered pair at pi over 4, that's the easy one because they match. So the ordered pair is root 2 over 2, root 2 over 2. And then you can just do the same thing here. Fill them in, changing the signs, S-I-G-N's, based on which quadrant you're in. And then we got one more. Example 6. I'm not even gonna write it down. Can you fill them in? What are your pi over 3 angles? We got pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. And then the coordinates are going to be the same, 1/2 comma root 3 over 2. You just make the right ones negative, and that's all there is to it. So right down there at the bottom of the page, he's drawn a handy dandy, beautiful unit circle for you. Turn the page and fill it in at the top on your own. So take a second. He's done quadrant 1, so the rest of it's easy. But identify the angles and identify the points. When you're done, compare your answer to your partner. Or we're back at the previous page. If you get stuck and you're asked your neighbor or look up the previous page, sometimes in the other classes, we, make them, okay, quiz today, you're all gonna fill out in a circle. We're not gonna do that, but we are going to do problems like in example 7. So when you will need your unit circle is, pretend it's not there and you just have this. And you have to find the sign of 2 pi over 3. Well, you sine is y. And you know where 2 pi over 3 is on your circle. So it's the y coordinate at that point. That's why you gotta know your unit circle. Okay? So the y coordinate at 2 pi over 3 is what? Root 3 over 2. So the answer for A is root 3 over 2. Try, see how many of these you can do without looking at your circle. How many can you just remember? I think B is an easy one. I love the pi over 4s because I know sine and cosine are both going to be root 2 over 2. I just need to worry about if they're negative. Is the cosine at 5 pi over 4 going to be a positive or negative number? Negative, because where's 5 pi over 4? Quadrant 3, and x and y are negative in quadrant 3. So B is negative 5 pi over 4. All right, go ahead, fill in some more and we'll check them. You for answers, so let's get some answers for
Yeah.
oh, okay. I'm all done already. Here we go. What'd you get for C? Okay, say it loud so they can hear. Root 3 over 2 is C. That's what I got. Is that what you got? All right. Chloe, what'd you get for D? Negative square root 2 over 2.
Root 2 over 2.
Yep, negative square root 2 over 2. That sounds good. E. Lydia, what'd you get for E? Negative 1/2. Perfect. F. Valentine, what'd you get for F? Negative 1/2. Don't you wish your last name was Valentine this time of year? So cool. All right. G. Evan, what'd you get for G? Okay, that's all right. Keep working. Right now, or we'll have you do it. Negative 1. How did he know negative 1? He looked at his circle, pi is over here, and he said, oh, the x coordinate's negative 1 over there, so the cosine is negative 1. See how easy it is? If you know your circle, it's so easy. Okay, Sydney, did you get to H?
Yeah, I got
Negative 1, perfect. I, Caitlin, did you get that far? Negative 1/2. Perfect. Perfect. So I don't know what you did wrong, but you got that one right. J, Celeste, 1/2. Sam, okay?
Okay, 0.
0, very good. And finally, L, Charlie,
0.
0. How are we, okay? Got the hang of that? All right. Go to the back of page 15. I don't want to beat a dead horse. You have already filled in a bunch of ordered pairs. So the back of page 15, see, you got circles with points to fill in. We're not gonna do that, but the top one is what kind of angles? Pi over 6, pi over 4, pi over 3. Those angles in the top picture are the pi over 6s. So pi over 6, 5 pi, 7 pi, 11 pi, right? And you know those points, okay. How about the middle one? What are the middle ones? The middle ones are the pi over 4s. And the bottom ones are the pi over 3s. Okay? If you want to practice more, there's do that. Go ahead and do that. We're not going to do that right now. We're going to turn to page 16. Now there is no unit circle staring us in the face, and we have to do problem 1. We have to find all of those things. So do not go back to your unit circle. Draw a new one if you need to, but here we go. No notes, pretend this is no notes. We're going to answer on page 16, problem number 1. All 4 of those on problem number 1 without referencing the unit circle we've already done. If you need to draw your quadrant 1 like I do here or something, that's fine. Let's start from scratch. Opposite over adjacent. Alberto, did you get A?
Yeah, I did.
What'd you say?
I got negative my half.
Are we gonna agree or disagree? Alberto says A is negative 1/2. Agreed. Perfect, good job. How about B? Anybody get B, Charlie?
Negative root 2 over 2.
Negative root 2 over 2. Quadrant 4. Why is negative signs? Okay, C. Anybody get that far? Caitlin, I know you want to answer.
2 over 2 root
So tell me that again.
3. Like 2 over 2 root 3.
Now, what about that? Can that be reduced? So that would be 1 over root 3? Is that okay? What quadrant am I in? Be careful. 5/6. Remember, this is a whole pi, so 5/6 would be here. And what do I know about x and y in quadrant 3, or quadrant 2? 1 is positive and 1 is negative. So when I make the tangent fraction, it's going to have to be negative. So you got the right number, you just want to make sure you reduce it and get that sign correct. Yes, I did. Okay, so negative 1/2 divided by root 3 over 2, x times division by fraction, right? By reciprocal. Okay, And the last one, D, 7 pi, that's a big angle. Where is 7 pi located? It's just pi. Just pi. Because 6 pi is just 3 spins, so that extra pi. So the cosine over there is -1. All right, number 2. Which one doesn't belong? And there's, depending on how you look at the problem, there's different ways you can answer this, but give a convincing argument for each answer choice. I'm going to jump out and do the first one. I'm going to say that cosine one doesn't belong because it's the only cosine. Okay? All right. Anybody have a different? Miss Valentine? So that sine negative pi over 3, that's a negative angle. It's the only negative angle, so that one might not count. All right. Anybody else have a thought? Bill?
11 pi over 6 is the only one.
11 pi over 6 is the only one. Actually, that's not true. Where's negative pi over 3? What if we evaluated those? What is the sine of 2 pi over 3? The sine of 2 pi over 3 is... Isn't it √3 over 2? And how about the sine of negative pi over 3? Isn't it also √3 over 2, only negative? How about the cosine of 5 pi over 6? The cosine of 5 pi over 6. Won't it be negative √3 over 2? Look at your unit circle if you're not sure. Keep me on my toes. And what's the sine of 11 pi over 6? -1/2. So I might say this is the one that doesn't fit because it's the only one that has a positive value. Or I might say this one doesn't fit because it's the only one that's not a √3 over 2 version. So there's lots of different ways we could look at it. Okay, we all right with that? Okay, and the last one, find the exact coordinates of points A, B, and C. Find the exact coordinates of points A, B, and C. All right, take a second, see if you can figure out what to do. Kind of buried in there, the angle is 5 pi over 3. So we are looking at the 5 pi over 3 angle. That's the angle that we've got. But he's built it on different size circles. So the angle isn't changing. But the x and the y are changing based on the radius of the circle. Yeah, yeah. Remember this, kids, don't make the problem harder than it is. Remember this. You know your radius, you know your cosine, multiply them together, and that gives you your x. For point A, isn't that the unit circle, point A? So point A is just going to be 1/2 negative √3 over 2. And then you get point B, so this is 1/2. This right here is 1/2. And this is negative √3 over 2. So to get point B, we'll just take those numbers and multiply them by 2. And And then to get point C, we'll take those same numbers and multiply them by 3. Easy peasy. All right, got a little review thing here. So what this little exercise is called odd one out. So it's kind of like what we just did. He gives you 3 problems, 3 little things. You figure out what the answer is, and then one of them will match, okay? So do it with your partner. You need a partner for this. So we can take the rest of the period and get as much of this done as we can. Your unit circle is your friend. Feel free to use it, but remember that eventually you have to double do this one. So on one side are the problems, and on the other side are where you write down your answers. And then ultimately, you're gonna take all the ones that don't fit, all the odd ones out, and add them up, and get an answer down there. All right, so let's see what we get done. We don't have much time, but.
Are we doing the number? Are we doing the number or the answer?
Three homework will be due on Monday.
Wait, is it X or no?
It's not next. Right, I gotta get the box down there.
Oh, this is another fine. I finished mine, but the thumb it looks like a undefined. Never mind. Oh. I'm gonna check A again. I don't mess up. See what we get.
Did you get for 5 Yeah, you can do that.
You guys finding this pretty easy, really? I mean, it's pretty easy stuff. What are you shaking your head for? Yeah. So you haven't read any of this yet?
Oh, no, I'm working on this one right now.
Okay.
Just take me a minute.
Let's do a quick double check. I did not do it, I messed around with my candygram box. What was the odd one out in number 1?
C.
C? I don't know, I'm asking you. C? How about number 2? A?
D.
3 is B? 4 is B? And let's just stop with 5. 5 is C? Right? Everybody's good? Okay, has anybody finished the sheet yet and added them all up? What did you guys get when you added? -1/2? Did you guys get it added up? Nobody yet? Okay. I don't know, we'll kind of shoot for that. We're almost out of time. Go ahead and finish as much as you can. Remember, the 3-3 homework is due on Monday. And remember